Okay, picture this. A laptop that, I don't know, lasts seemingly forever on battery, but still has the muscle for actual work.
Right.
There's talk, serious talk,
Mhm.
about ARM-based Windows laptops grabbing maybe, what, 30% of the market
So
soon?
it's a huge potential shift.
And right at the center of all this buzz is this chip, the Qualcomm Snapdragon X Elite.
Yeah.
So today, we're doing a deep dive.
Yep.
We want you to get the lowdown quickly, what this chip means, why it's such a big deal, and, well, how it might change what you look for in your next laptop.
And we'll try to cut through the jargon. We've looked at the architecture, the performance claim, the software compatibility, which is huge, and how it stacks up.
Let's get into it. The big idea here seems to be
Yeah.
ARM finally arriving for Windows in a serious way.
Exactly. I mean, we've seen Windows on ARM attempts before, but this feels different.
How so?
Well, look at the backing. Microsoft, Dell, HP, Lenovo, all the big names are launching devices. That signals real confidence, unlike maybe previous efforts. And technically, it's built on a 4-nanometer process. Super tiny transistors, basically, meaning more power, less heat, better efficiency.
Right.
And inside is Qualcomm's own 12-core Orion CPU. That's the brain, custom designed for this balance of speed and, crucially, battery life.
Okay, custom CPU, big OEM support. But the elephant in the room, right, will my software work? We're all used to by 86 Windows.
That is the critical question, and the answer revolves around emulation. Microsoft built this thing called Prism right into Windows.
Prism, like a translator.
Pretty much, yeah. It lets this ARM chip run apps made for the old x86 processors. Now, early reports, well, they're a bit mixed, honestly.
Mixed how? Like good for some things, bad for others?
Sort of. If you check places like Reddit, you'll see people saying for everyday stuff, email, web, Office, it's surprisingly smooth, like you might not even notice.
Okay, that's promising.
But then you try to fire up, say, some heavy-duty pro software or certain games, and that's where the translation layer, well, it can show its limits. You might see a performance hit.
So it's not quite magic yet. Are there examples? What can it handle okay under emulation?
Well, early tests were interesting. Adobe Premiere Pro, for instance. People were managing 1080p video editing using the emulated version.
1080p editing is pretty decent for on the go.
It is. It shows potential. But it also showed, yeah, there's still a gap compared to running it natively on x86 for really intensive stuff. The good news, though, is they are actively working on Prism.
Improving the translator.
Exactly. Microsoft and Qualcomm keep adding support for key x86 instructions, things like AVX, AVX2. These are extensions, lots of modern apps, and even games like Starfield need to run properly.
Okay, so compatibility is improving. What about gaming specifically? That's always a big one.
Gaming. Yeah, it's definitely an evolving picture. Initially, there were big hurdles with anti-cheat systems.
Ah, the kernel level stuff that digs deep into the OS.
Precisely. Those caused problems. But the list of playable games is growing. There are community sites like worksandwoe.com tracking what runs. And a really big development was Epic Games and Qualcomm working together. They got easy anti-cheat, the system Fortnite uses, working on these Snapdragon X PCs.
Okay, Fortnite works. That's a major hurdle cleared.
It is. But, other anti-cheat systems, maybe like Riot's Vanguard, might still be tricky. It's not universal yet.
And performance.
Yeah.
Even if a game runs, does it run well? Can this replace a gaming laptop?
Probably not for serious gamers, not right now. The integrated Adreno GPU, the graphics part, it's capable, but it generally won't match a dedicated gaming GPU or even some of the top-end integrated graphics from Intel or AMD, especially in demanding titles.
Anyway, playable frame rates in some games, maybe older ones, but not a powerhouse.
That's a fair summary. There's also this Windows feature, Automatic Super Resolution, or Auto SR. It tries to upscale the image to boost frame rates.
Does it work?
Sometimes. Its effectiveness really varies game by game. So yeah, gaming is possible, increasingly so, but these aren't being sold as high-end gaming rigs primarily.
Understood. Okay, shifting gears from gaming. What about professionals? Creative work, maybe CAD, coding. Can they handle that serious stuff?
This is where it gets interesting again. That Adreno GPU, Qualcomm, claims up to 4.6 TFLOPS of power. That's a decent amount of graphical grunt. And it supports modern standards like DirectX 12.
So, potential for pro apps.
Definitely. We already mentioned DaVinci Resolve video editing. Because it has native ARM64 support, it runs incredibly well. It even uses the chip's special AI engine, the MPU, for features like Magic Mask.
Ah, so native is the key.
Native is absolutely the ideal scenario for both performance and power saving. We saw Premiere Pro doing okay-ish with 1080p under emulation,
Right.
but native apps like DaVinci Resolve just fly. Blender, the 3D software, also has native ARM support, which is
Right.
great. Performance there compared to, say, a high-end desktop GPU will vary, of course.
Makes sense. What about things like CAD, AutoCAD, Fusion 360, stuff engineers use?
That's more mixed, based on early feedback. Running under emulation, basic modeling might be fine. But complex assemblies, heavy calculations, you might hit performance walls there. Compatibility with things needing low-level hardware drivers, certain VPNs, antivirus, sometimes printers or scanners, has also been a bit patchy initially. Things like NordVPN, AutoCAD itself had launch day issues reported.
So native apps are best, emulation is getting better but has limits, and some specific software, especially with drivers, might still be tricky.
That sums it up well. But Qualcomm seems committed. They're releasing driver updates frequently, even beta drivers directly through their own software center now, which is new.
Direct drivers, not just through HP or Dell.
Yeah, which could mean faster improvements.
Good.
They've already pushed updates specifically mentioning better performance or compatibility for games like Helldivers 2, Paul World, even Kingdom Come Deliverance II, and apps like Photoshop and Blender.
Okay, so active development is happening. Good sign. Let's talk about maybe the biggest claimed advantage: battery life and efficiency.
Right. This is where the Snapdragon X Elite really seems to shine. The power efficiency claims are substantial, and reviews are backing it up.
Like noticeably better than current laptops.
Often, yes. We're seeing reports of battery life easily beating comparable Intel and AMD systems, and in some workloads really getting into that Apple M series territory for longevity. For someone working on the go, that's huge.
That is a game changer. Is there a catch? Does it throttle performance to achieve that? And what about heat? Does it run cool?
Well, battery life always depends on what you're doing, right? Running demanding emulated apps will drain it faster than native ones or just web browsing. And yes, Windows has power modes that will trade some performance for longer life.
Okay. And heat. Are these fanless?
No, typically they do have fans, unlike, say, an iPad or some other ARM devices. For light work, reviewers say the fans are often off or very quiet.
But under heavy load?
Yeah, under sustained heavy load, the fans will kick in and you'll hear them. Some comparisons suggest it might run a bit warmer than Apple's M3 chip when really pushed hard. But again, thermals depend a lot on the specific laptop design, how the manufacturer configured the power limits.
Okay. So efficient, great battery, but not silently cool under all conditions.
Yeah.
Makes sense. How does it stack up against the competition? Intel's got Lunar Lake coming.
Yes, the big showdown. That's definitely the main competitor in this ultra-portable space. It's an interesting contrast in approaches.
How so?
Snapdragon X Elite is ARM-based, focusing on efficiency and that high 12-core count for multi-threaded tasks. Intel's Lunar Lake is sticking with Biardi 6, but using a hybrid design, mixing powerful P cores and efficient E cores, up to 8 total cores.
So different ways to balance power and performance. What are the benchmarks suggesting?
Early comparisons indicate Snapdragon X Elite often pulls ahead in multi-core tests, especially under sustained load where its efficiency helps. It seems really strong when tasks can use all those cores for a while, particularly on battery.
And Lunar Lake?
Lunar Lake might have an edge in single-core speed for tasks that need quick bursts of power on one core. And its integrated graphics, the new Intel Xe2, look quite potent, even promising ray tracing support, which the Adreno GPU doesn't have.
Interesting. What about AI? Everyone talking about MPUs.
Both have dedicated MPUs, yeah. The claimed performance, measured in TOPS trillions of operations per second, seems pretty comparable between them. So for those on-device AI features Microsoft is pushing with Copilot plus Bay, both should be capable.
So it's not like one is clearly better across the board.
Not really, no. It looks like Snapdragon X Elite might be the choice if your priority is maximum battery life and strong multi-core performance for sustained tasks. Lunar Lake might appeal more if you need that peak single-core speed or better integrated graphics for gaming or creative work.
It really comes down to how you use your laptop.
Precisely.
Okay, so wrapping this up, for you the listener, hopefully this deep dive gives you a solid handle on the Snapdragon X Elite. It's a really significant move, bringing ARM seriously into the Windows world.
Yeah, the big strengths are definitely that power efficiency, the battery life, and its potential in tasks that use many cores, plus the AI capabilities.
But the flip side, at least for now, is the reliance on emulation for older software, which can impact performance for really demanding apps in high-end gaming. And the integrated graphics, while capable, aren't top of the line for gaming.
Right. There are trade-offs, as with any big tech shift. You need to weigh that amazing battery life against whether your specific crucial software runs perfectly yet.
It definitely feels like a turning point, though, and it makes you think. As these processor lines blur, with ARM getting more powerful and by 86 getting more efficient, what becomes the deciding factor for your next machine?
That's the fascinating question, isn't it? Is it going to be about raw benchmark numbers, or that all day and then some battery? Or will it just be about knowing absolutely that every single piece of software you might ever need just works seamlessly?
And with emulation like Prism getting better all the time, how long before we stop even thinking about whether it's ARM or by 86 underneath? Will it just become invisible?
It really makes you wonder about the future of personal computing. A very interesting time.